Okay, let's find the area of a kite. Now, you know a kite is a kite if it meets certain conditions. Okay, remember how they have to have adjacent sides congruent? And the diagonals have to be perpendicular. Well, or they just are perpendicular. But anyways, those are some things that you have to remember. One diagonal bisects the other. And the diagonals are perpendicular. That's the perpendicular side. Okay? Those things are important to know. So whenever you see a shape that has those things, you can use that information to help you solve it. Okay, so this has us draw the diagonals in for the shape again. So those are your diagonals. They're perpendicular. And this one is cut in half. One of these is d sub 1. We'll make the longer one d sub 1. And the other one is d sub 2. I draw on the outside because it's just easier to label, I suppose. Determine the area of the rectangle. So it's kind of the same as the last one when we worked on the rhombus. D sub 1 times d sub 2, base times height. Okay, there's your base, and there's your height. Okay, over here it says, what is the area of the kite? This one's harder. I mean, it's not hard, but I have to bust out a lot of variables, and I don't really feel like doing it right now. These ones don't. This point right here doesn't divide this in half like the other one. This one is divided in half, so that's a d sub 2 or 1/2 of d sub 2 right here. The length of this, and so that's the length of this also. So I got 1/2 d sub 2. I don't know the length of this and this though, and so. I'm sure there is a way to do it to derive this formula, but I'm just going to give it to you guys. It's the same as the rhombus. It's 1/2 d sub 1 times d sub 2. Okay, and I don't want to spend any more time on this. So let's just look at the examples here. Okay, first one, it gives us some labels. It says, determine the area of the kite below. The longest diagonal is 6 inches. So I'm going to label it like this. This is going to be 6. And the other diagonal is 4 inches. Also be kind of fast. 1/2 times 4 times 6. 1/2 of 4 is 2. And then we have a 6. That's 12. 12 inches squared. Now let's do the other one. What's the length of the longer one? Yep. No, wait, not 13. 13 is just this part right here. 18, yes. Okay, what's the length of the shorter one?
12.
How do you know it's 12? It only says 6. Oh yeah, it's bisected. That's the other thing you have to remember. Okay, so we just have to go 1/2 of 12 and 18. And write the multiplication a different way there. 1/2 of 12 is 6. We have to multiply it times 18. 6 times 10 would be 60, and 6 times 8 is 48. So we have to go 60 plus 48 in our heads. That's 108. And it doesn't give us the units again, so we'll say units squared. Got anything else? Nope, just this Venn diagram. Alright, so what I want you guys to do right now is try to write something in each section. Okay? This is a section right here. Oops. This is a section right here. We have 1, 2, 3, 4, 5, 6, 7. There's 7 sections. Right now, I'll give you guys a minute. See if you can write something in each section. It's not talking about the shapes, it's talking about the formulas. See, it says about the 3 formulas. Now, I know you guys have done Venn diagrams before. If you put something right here in this space, that is especially unique to the trapezoid. If you put it in this space, then the rhombus and the trapezoid have that in common. If you put it in this one, all of them have it in common. Okay. Did anybody get something for trapezoid? Let's see, Steven, did you write something in trapezoid? What'd you get?
No, I remember doing trapezoid.
Dog, you didn't get trapezoid right here? Okay, what about George? You got something there? For trapezoid, yeah. You got anything in trapezoid? No? Oh man, this is kind of difficult. David, lay it on me.
It uses the base measurement.
Okay, that's good. It uses the formula. It uses the base measurements. I'm just going to say bases. It uses the bases. That's true. Alright, that's cool. We only really need to have one thing in there, but anybody get anything different? Go ahead, Alyssa.
It uses the height in the formula.
Ooh. I'm just going to add to this one. I'm going to say and height. Okay, so use the bases and the height. That's good. Give me another. Nobody? Okay, then what about rhombuses? Is there anything unique to rhombuses in terms of the formula? Karen, did you get anything? No, nothing there? Devin? Did you get anything? No? Devin, you wanted to share another space? Did you get anything in another space?
No, all I did was trapezoid.
You only did trapezoid one?
Yeah.
Oh man, we already passed that one. Did you write the same thing? Okay. Vanessa, give me one. Anything. Any space. You give me something in any space.
I got nothing.
Shush up. Are you serious?
I got nothing.
Girl, come on. Did you even look at them? Did you? Okay, anybody can volunteer? I'm tired of calling people and they're going, oh, I didn't do anything. No, I already called you, Alyssa. Go ahead, Nicholas.
For all in the middle.
Yeah, in the middle?
All of them.
Uh-huh.
They're all multiplied by 1/2.
Oh, all multiplied. Shut up, you did not have that, Vanessa.
See,
Then why didn't you tell me?
The half's in the
Oh, you're a
sentence.
wussy, that's why. You have something in every single space, why didn't you tell me? I'm afraid of what people will say about me. All multiplied by 1/2. Alright, go ahead, Sam.
Both the rhombuses and kites use the diagonals to figure out the area.
Yeah, use diagonals to figure out, I'm going to say figure area. Very nice. Alright, give me another one, somebody. Fill in another space. Go ahead, Drew.
Same formula for rhombuses and kites.
Same formula. Ooh, and it's the same formula. Oh, you're right. Same formula. Alright, cool. Maybe else got something different. It could be in the same space or a different space. Come on. Now, I asked you guys, I challenge you to fill in something in every single one of these. But when you guys look up here, it says be sure that you write at least one item in at least 4 sections. So we got 3 sections. We got to have one more section. Come on. Come on, anybody? Alright, so we can't figure out anything else, but that's okay. What? Oh, well, that's kind of weird. Alright, we're done.
No, you're